When you're planning a massive project, what do you think about? The big stuff, right? Well, what if I told you that something as simple as your cable tray could be one of the most important financial decisions you make? Today, we're going to dig into the huge structural and financial advantage of ladder cable trays. Let's just jump right in with a number that'll get your attention. 2.3 million yuan. That is the estimated savings on one single project. And get this, that's not savings on labor or supports, that's just the cost of the copper wire itself, just the raw material. So, I know what you're thinking. How on earth can a simple piece of hardware, a cable tray, possibly lead to that kind of savings? Well, the answer is all about some really clever engineering. And honestly, it's pretty fascinating. To figure this out, we're going to start with a real-world case study. This isn't just theory, okay? This is about a single decision made on a huge petrochemical expansion in Shandong that had absolutely massive financial results. All right, so here are the details. The project needed to run 12 kilometers of high-voltage cable, and the challenge was a classic one for engineers. Find a way to cut costs without cutting any corners on safety. By making one critical switch, going from a solid-bottom tray to a ladder tray, they could actually use smaller copper conductors. And that one simple change, that's what led directly to that 2.3 million yuan saving. So how is that even possible? Well, it all boils down to a super simple but really powerful idea. For a cable tray, its physical shape, its geometry, is its destiny. The way it's built is what determines exactly how it performs under pressure. Let's just look at the basic construction. On the left, you've got a ladder tray. It's exactly what it sounds like, right? Two side rails connected by rungs. Simple, open, strong. Now, on the right, is a perforated tray. It's got a solid sheet of metal connecting the rails, with a bunch of holes punched in it. You might think that's not a big difference, but oh, it has massive implications. Okay, now this is where it gets really cool. The side rails of a ladder tray, they act just like an I-beam. You know, one of the strongest and most efficient structural shapes we know how to build. That gives it an incredible load-to-weight ratio. A perforated tray's base, on the other hand, acts more like a simple flat plate. It's just not engineered to handle the same kind of stress. And here is the proof in the numbers. I mean, look at this. These are the load classes based on the international IEC standard. Ladder trays are comfortably handling anywhere from 75 to 200 kilograms per meter. Perforated trays, they pretty much top out around 75. That is a huge, huge difference in performance, and it's all because of that smart I-beam geometry. But wait, because structural strength is only half of the story. The other piece of the puzzle, the other key to those savings, is something you can't even see, but it's absolutely crucial for any electrical system: airflow. Now, this chart shows something called an ampacity derating factor. It sounds technical, but the idea is really simple. It's basically a score for how much you have to lower a cable's power capacity because it's getting too hot. A ladder tray's open design lets all that heat escape, so gets a great score, 0.85. An enclosed tray, though, it traps the heat, and its score plummets all the way down to 0.60. And here's why that number matters so much. That difference isn't just an abstract number on a spec sheet. It's the real-world difference between your cable working just fine or you having to buy a much thicker, heavier, and way more expensive cable to handle the exact same electrical load. This is precisely the key to that Shandong project. Better airflow meant they could use smaller, cheaper cables. Simple as that. All right, so we've got the principles down. Now let's see the proof. Because these advantages aren't just theoretical, they're delivering real, measurable results on some major projects right now. Let's run through a few quick-fire examples. First up, just a number for you: 40. 40 what? 40 minutes. So this comes from Beijing's utility tunnels. For every single 10-meter section of cable they had to replace, using an open ladder tray instead of a closed-off conduit saved the work crews 40 minutes. Think about how much that adds up over the years. The easy access for maintenance is a massive operational win. All right, our next data point isn't about time saved on one task. It's about how often you have to do the task at all. We're talking about going from quarterly checkups to just once a year. Check this out. At a desalination plant on the coast of Oman, I mean, you can't imagine a much harsher, more corrosive environment, right? Salt, air, moisture, brutal. They use ladder trays made from 316L stainless steel. That material, plus the open design that lets moisture escape instead of just sitting there and causing rust, slash their maintenance cycles from every 3 months down to just once a year. And for our last piece of proof, get a load of this spec. 150 kilograms per meter. That is some serious heavy-duty performance. This was the requirement for the Chengdu metro system. They needed a tray that could reliably carry these super heavy, super critical cables for signals and power all underground. In a public transit system, you have zero room for error. Structural failure is simply not an option. That I-beam strength we were talking about wasn't just a nice to have, it was absolutely non-negotiable. So let's bring it all home. We've seen the engineering theory, and we've seen the real-world proof. So that leads us to the final big takeaway. Knowing when choosing a ladder tray is the only logical, non-negotiable choice you can make. So here's your checklist. You should be thinking ladder tray whenever you need serious load capacity, when you want to have longer spans between your supports to save on installation, when you absolutely need maximum airflow so you don't have to buy bigger cables, and for sure when you're working in a tough environment or when you know that easy maintenance is going to be a priority for years to come. Ultimately, it really just boils down to this powerful idea. Your cable tray's geometry isn't some passive piece of hardware. No, it's an active decision that will literally dictate your project's budget, its long-term reliability, and its overall safety. And that leaves us with one final question for you. When you look at your projects, is your cable management system a structural asset that's adding value and saving you money? Or is it just another component that could become a serious liability down the road? Because as we've just seen, that one choice can make all the difference in the world.